Okay, in this video I will show you how to solve quadratics by factoring. So you'll remember factoring from Algebra 1, so you've already factored. But we'll review this and make sure that you remember all of the steps. So the first thing that we're going to review is how to solve a quadratic by factoring when it's already factored. So we're starting off easy, so let me show you some problems like that. If you look at these four problems, well, these are quadratics because when you multiply x by x, you get x squared. So that's the definition of a quadratic, is having that squared variable. Down here it's b squared, here it would be v squared, and this is n squared. So all of these are already factored, so the hardest part is already done for you. So what that means is they're set up and they're ready to solve. So in this case, if I have x plus 7 times x minus 2 is equal to 0, well, since it's equal to 0 here, that means that any one of these expressions could be 0 to make the whole statement true. So we take both of these. We take the x plus 7, and we set that equal to 0. So we're saying, what would make this 0 right here? Then we take the right parenthesis, x minus 2, and we set that equal to 0. And then we solve, and we see that, well, in this case, if I subtract 7 from both sides, and in this case, if I add 2 to both sides, that gives me the answer of x is equal to negative 7, and x is equal to positive 2. So pretty easy. Those are my two solutions, and remember, you will always have two solutions when you're solving a quadratic. Now the two solutions may be the same number, so that confuses some people. So we'll come up with one of those examples soon. Okay, in this example, let's say 2n plus 7 times n plus 3. Again, we're just going to take both of these and set it equal to 0. And I'll do these fast. N plus 3. So my final answer here is n is equal to negative 7 halves. I divided both sides by 2. And on this side, I get n is equal to negative 3. That's a negative. Okay, so I have my two answers here. Down here, b plus 7 times b plus 8 is equal to 0. So I'm going to just jump to the final answer. That's b is equal to negative 7 and b is equal to negative 8. And notice that you can check that. If I plug in a negative 7 here, that becomes 0. 0 times any number would give me 0. So plugging in a negative 7 gives me 0 times 1. Well, that's 0, so it checks. If I plug in a negative 8 here, negative 8 plus 7 gives me negative 1. Negative 1 times 0 equals 0. So both of these are solutions. Alright, before I move on to the next one, let's find an example where I get two that are the same answer. Alright, right here. Let's look at this question right here. P plus 2 squared. Well, this is already factored. So let's write this twice. That's p plus 2 and p plus 2 is equal to 0. So I do get two answers, but in this case, they are identical. So I have p plus 2 is equal to 0 and p plus 2 is equal to 0. So my p is equal to negative 2 and p is equal to negative 2. So in this case, I have just the one p because they're the same. So that's the one exception to that rule of always having two answers. Okay, now let's look at the next type of solution we're going to come up with when solving for quadratics, and that's when the leading coefficient is equal to 1. So we're going to see that in this case we have to factor. It's not going to already be set up in factored form. So let's look at one of these problems. So down here we can see this problem right here. We will have to factor this problem though, so we need to factor this. So we have a squared minus 10a plus 24. So first thing is I'm going to check, is it equal to 0? So is it equal to 0? And it is, yes, it's equal to 0. So I'm set. I can come down here and I can factor. I'm going to factor this by making it two sets of parentheses. I have two sets of parentheses. And here, since my leading coefficient is 1, I will always have this variable in both of the parentheses. Now another thing I know is that the middle parentheses is a negative and the outside parentheses is a positive. Well, that tells me that both of these will be negatives, because a negative times a negative gives me a positive, which this answer out here is the multiplication, and a negative plus a negative is a negative, so that gives me the negative inside here. So now what I will do is look at the 24, and what are my factors of 24? Well, my factors of 24 are 2 and 12, 6 and 4, 8 and 3. So these are my factors. And I'm going to ask the question, or I will ask the question, which one of these numbers adds to give me the middle term, 10? If I have two negatives, which one adds to be 10? Well, they're both negative here, so negative 2 and negative 12 would add to be negative 14, so this one doesn't work. Negative 8 minus 3 gives me negative 11, so that doesn't work. But the 6 and the 4 does work. So in this case, I factored this to 6 and 4, and I can go through and solve, setting both of these equal to 0. And you'll see my answer is a is equal to 6 and a is equal to 4. And always as the last step, you can take these and substitute them back into your equation and make sure that they end up equaling 0. Okay, so the next step is to solve not when the leading coefficient is equal to 1, but when the leading coefficient of the quadratic is not equal to 1. So we'll have some number in front of the x squared, or the variable squared that's not 1. Let's take a look at that. Well, right here we have the variable, it's v squared, and the leading coefficient is not 1. So these type of equations, the leading coefficient is not 1. All of these, none of these are 1. Alright, well let's take an equation like this, and let's move it over here so we have more space. So we have our equation 8b squared plus 49b minus 49 is equal to 0. So the first thing is, let's take the leading coefficient, which is 8, and let's break that down into the factor trees. So we have 1 and 8 and 2 and 4. Now let's take the last coefficient, or the constant last term, and let's break that down. So we have 1 and 49 and 7 and 7. Solving this through the guess and check method, I will set my parentheses up, and I'll set up everything I know. Since this is a negative and this is a positive, well, two things that a positive and a negative multiply to be a negative, and a positive and a negative can add to be a positive if the positive is the bigger term. So we know we have a b here. We We know we have a b here. And I'm thinking, what two numbers multiply to be 49 and add to be 49 with a leading coefficient? So I'm going to have these terms in here. So let's do this in blue. Just looking at this and going through different scenarios in my head, I think it will be the 8 and the 1 here. So I'm going to choose an 8 here, and the 1 right there. I don't have to write that in. And the 7 and the 7. And now let's check this to see if it's right. And I'll check it in green. So 8b times 8b, well, that's 8b squared. 8b times negative 7 gives me negative 56b. 7 times b gives me a positive 7b. And 7 times negative 7 gives me a negative 49 is equal to 0. Okay, so with this check, negative 56 plus 7b would give me a negative 49. So I'd have 8b squared minus 49b minus 49 is equal to 0. So I don't want this negative here, so I have one thing wrong, and that's that this 8, it goes on this side. So now you'll see that when I change that, that would make this positive 8b times 7 is positive 56, and negative 7 times b is negative 7b, which would make that a positive. So this works out. And after I factored it, well, now I can solve. So I can say b plus 7 is equal to 0, and 8b minus 7 is equal to 0. B in this case is negative 7, and here's two steps. 8b is equal to 7, b is equal to 7/8. And now I have my two answers. Last step, of course, is to plug those in and make sure they equal to 0. Alright, that was the most difficult objective. Now our last objective is we will solve quadratics when the equation is not in standard form, and that just adds one step, and that step is put the equation in standard form. So it's just rearranging it so that the equation becomes in standard form. So let's take a look at that. So here are a lot of equations that are not in standard form. If you look at all of these, they're not in standard form. Well, right here, due to the negative 4 being on this side. So in this case, all I have to do is, right here I have the 5 on the right side. Well, for standard form, I need to have this equal to 0, so I need to subtract 5 from both sides. That would give me 2v squared plus v minus 10 is equal to 0. Now I'm in standard form, and I can go through like the previous problem and solve that. If I look at this one, again, this is not in standard form, so let's put this in standard form. And I'll put this in standard form by adding x to both sides and subtracting 6 from both sides. So that gives me x squared plus x minus 6 is equal to 0. And just in case you didn't get that, let's do one more. What I will do is add n to both sides. That gives me negative 5n squared plus 2n minus 2 is equal to minus 2 minus 6n squared. Now that n goes away. Now in this case, I want to get the 6n squared to both sides, so I'm going to add the 6n squared. That gives me n squared plus 2n minus 2 is equal to, well, these cancel out, so I get minus 2. Last step is let's just add 2 to both sides. And now I have n squared plus 2n is equal to 0. This actually brings us up to an interesting quadratic. So let's solve this just so I can show you guys how to solve this one through factoring. This one, if I ever end up with n's but I don't have the constant at the end, I can just factor out an n by itself, and what I'm left with is n plus 2 is equal to 0. So in that case, I have n is equal to 0, and I have n plus 2 is equal to 0, so therefore n is equal to negative 2, and those are my two answers. Alright, you'll have lots of practice on the worksheet and on today's activity. If you need help, make sure you ask.